Welcome back to this channel. In today's session, we dive straight into presenting categorical data in R. Assuming you have already installed R and RStudio and grasped the basics of R, we jump into hands-on practices with real data set. This video in particular focuses on the 3 activities. One is importing an Excel file to R, second one generating frequency table, third one creating bar charts and pie charts for categorical variable. Let's get started by the first part. What the first part is nothing but installing and loading necessary packages into our working environment. First, we install the package that we need to have for the particular task. For example, for reading external Excel files to R, we need to have this read Excel package. So we have to install this package first. Then for enhanced frequency table, we may make use of this DesktOols. So the next step is loading into R session, so that we are able to make use of functions from those packages to our particular activities. So this can be made through library function. We write library, then the package name. Having loaded these packages, what the next step is importing and explore the data set. Right? We import through this code what the cases look like, what the structure of the data set, what the column names, what the comprehensive summary statistics can be explored here around as a second step. Then we begin creating frequency tables for maritime status, then bar chart for maritime status, pie chart, right? This all step by step will be explained in practice in R. In doing so, we will use the RStudio, which is popular IDE for R. So let us start importing the Excel data into R. This data, which is now named to be HHS, meaning that household survey, is imported using read Excel function. Read Excel function takes in the file name or the path for the file name to be imported, right? Now our file is in our working directory, so simply we write the name of the file only, that is DHHUXLSX, right? This is Excel file, so the extension is Excel. So let me run this line. Right, successfully imported. Here, as we can see, this is no error. Having imported, what the next step is exploration. For example, to see the 6 rows of our data set, I can use head function, then the name of the data set, right? Then run this code line. Wow, this is to be generated, right? This is nothing but our data set consists 3 elements, right? Age, marital status, family size, marital, which is 6 by 3. I can see also the structure. What structure type that household survey data is. This is nothing but I can make use of this stir function from R base function. This is nothing but the structure of our data is data frame structure, consisting 3 elements: age, marital status, family size. So the data type of each variable is given by this one: numerical for age, character for marital. We can see also the dimension, which is dimension of our data set name HHS, which is 800 by 3. This code generates the dimension of the household survey data, which is we have 800 rows or cases and 3 columns. So this dimension is 800 by 3. This can be generated through this command. And we can generate the summary statistic, summary of household survey. This can also generate these results. For example, this is variable wise, age, marital status, family size. The minimum age is 8 years old, maximum is 80. First quartile 27, median is 32, mean is 34, the third quartile is 40. The same is true. Family size has minimum value, maximum value, first quartile, median, mean, third quartile. This is nothing but comprehensive summary statistics of our data set. So before getting into the next step, exploring our data set, is also important to see the structure, the first rows of our data. For example, the last rows can be seen tail, by tail function, HHS. Let me run this one. Right, this is nothing but the last 6 rows. If I need more than 6, I can write, for example, 100. Right, the last 100, I can generate this one. What the next step is creating frequency table. I can make it of table function, right, table. Then I am making frequency table for which variable? For Maritial. This Maritial is part of the HHS, right? I can access through this operator, right? This is nothing but Maritial freq, right? I generate and I assign to this variable. So let me run this one. Right, this is successful. Let me print Maritial freq. This is nothing but the frequency table. It's a basic frequency table for Maritial status is nothing but the distinct values against with their frequencies. For example, here 49 of the households were divorced, 677 married, 15 separated, 11 single, and 48 widowed. Right, let me clear this one. This is the basic frequency table for Maritial status. But it could be better to add relative proportions, cumulative frequencies, percentages to be more informative. So how can we create table with proportions? The Maritial proportion column, Maritial proportion column by the function prop table. So this function takes in the Maritial frequency, Maritial freq, right? Maritial freq. This directly changes the Maritial frequency table into Maritial proportion. Let me print this one. Print Maritial prop. Right, let me hit run this one. The print line generates this one. Now, instead of the frequency, now this table consists proportion. Right? This 0.6125 is the proportion of 49 divided by 800. This function prop table converts frequency into proportions. That makes it easy to interpret categorical data in relative terms, right? So let me create more detailed frequency table, which consists of frequency, percentage, cumulative, and the distinct values of the variable under investigation. This can be created by Maritial detailed, which is created by cbind function in R, which combines 3 elements. One, frequency, which takes values Maritial freq, then percentage, which takes values this one Maritial prep times 100. The proportion is now easily converted into percentages by multiplying the Maritial prop by 100 and rounding to 2, right? Then the cumulative element, which is computed by cum_sum function, right? This cum_sum function takes in the Maritial frequency. When I run this one, right? Success. Now let me print this one. Print Maritial detail. Let me print. Wow, this is nothing but a frequency table with 3 elements generated, right? diverse it with frequency, diverse it with percentage, diverse it with cumulative figures. So this is somewhat more complete than the basic one, which includes percentage, cumulative, and frequency. This is nothing but creating frequency table using RBS functions. We can also create frequency table using functions from a package, which is a separate part package, which is called Desctools, right? We can create, in short, frequency. This is nothing but freq is for frequency. Frequency of which variable? For marital variable, for example. Variable which is part of our HHS dataset. This command now creates that we have created before, right? So in short, this frequency table, which is created by the above series of codes, can also be generated using this single code from, let me hit this one. Wow, this frequency table is now similar to that of to this frequency table that we have created by the series of codes. But what's the advantage here is that table is created with using single code, right? The same. The result is the same, but the difference is the way how to generate. So let us create bar chart for marital status. Plotting bar chart in R needs the knowledge of frequency table. So we have already created the frequency table for marital status, which is named by marital frequency. Now, based on this marital frequency, we can create bar plot. For example, bar plot function is useful to create bar chart in R that takes in the marital frequency or the frequency table. Marital freq, right? This is simply the basic bar plot. Let me run this one, right? This is nothing but the bar plot for our marital status variable. What's the shortcoming with this plot is nothing but this plot has no main title, no y label, no x label. So we can add these labels to this one, right? For example, main title can be bar plot of marital status. Marital status, right? And x label is nothing but marital status. Y label is frequency, meaning these numbers are frequency, right? And even you can change the color. This color can be changed into another color by this color command here. For example, let me change into blue, right? Now let me run this line, then I can get this bar plot, which is somewhat informative, right? This bar plot of marital status is the main title of the plot, and this y-axis is labeled to be frequency, the x-axis is marital status, right? Now the color is also changed into blue color. This is due to this input into bar plot function. Bar plot can be changed in such a way that it is to be more informative. What the next step is plotting pie chart. Pie chart is circular representation of qualitative data where that circle is divided into sectors, as many sectors as the number of possible values of the variable under investigation, where the area of the sectors is proportional with the frequency of those possible values. So let us see how can we plot such pie charts for marital status in R. This is nothing but using pie function. Pie, it takes the frequency table, which is marital freq, right? Pie marital freq. Let me hit this run, right? This is nothing but the pie chart for marital status, right? This highest area of sector is referring to married. This is divorced, widowed, single, separated. But it doesn't tell us the size of the frequencies. Actual frequencies or percentages could not be noticed here. But the area tells by itself something. Which one is more than the other, which one is less than the other. But to make it more informative, we can create further, such as calculating percentages, creating levels with category and percentage. Then we plot the more detailed pie chart in what follows. First, we calculate the percentage. PCT, percentage, can be created by this one. We multiply the marital divided by sum of marital freak, and we multiply by 100, right? 100, right? Then we round this one 2. Then this marital percentage, meaning the frequency is now changed into percentage and captured by this variable. What the next step is creating labels. For example, marital labels, right? What labels will be attached with the sectors of the pie chart, right? This can be created by paste function, which concatenates the names of the table, marital freak, right, with the marital percentage, and we can add this percentage symbol to see or to indicate this marital percentage is a percentage. Now let me run this one. Successfully run. Now let me plot the somewhat enhanced pie chart, right? Pie marital freak labels is the marital level that we have created here. This can be taken to that as is by copy paste. Then main, which is the main title of the chart, which is pie chart of marital status. This, right? What the other thing is color. Color can be rainbow. Rainbow has many colors, but therefore this gives us the following pie chart. When I run this, I come up with this more informative pie chart, right? This pie chart now is more colorful and informative. Why it is informative? This sector is labeled by merit, yes, but how much the area or the proportion or the percentage it takes can also be attached here. Merit 84.62%, diversity 6.12. This one, this diversity 6.12%, merit 84. This extra is created by this paste function, right? And combined by this pie chart, these all things in one. So this is more informative than the previous one. Now let us proceed to the creation of ungroup frequency table for family size. Family size is a discrete variable to which ungroup frequency can be created. So in R, we can create ungroup frequency table for such variables using the table function, similar to that of categorical variable. Now, family table HHS family size. This is nothing but the function which creates ungroup frequency table. We can assign this one into family size freak, right? Let me run this one, right? Create it, and let me see by printing this one. Print family freak, right? This is nothing but the basic frequency table for the discrete variable, which is family size here, where 1 up to 10 are the distinct values, where this one are the frequencies, right? Meaning that we have 8 households whose family size is 1, we have 45 households whose family size is 2. We have 21 households whose size is 10. This is nothing but the basic angle per frequency table, right? This is not well informative, so to make more detailed, we can perform some sort of codes in what follows. Now family size detailed come created by creating a data frame where family size is nothing but as numeric of the names of family freak, right? The names meaning that these are serving as a name or distinct values. This will be considered as numeric, but the names are this one, right? And we add frequency element, which comes from as numeric the family size freak from family size freak, right? This frequency starts from this family size freak that we have created here around, right? And we add another element, percentage, right, which is rounded into 1 or 2, proof type family this one, and which is multiplied by 100 and rounded into 2. What the other thing is cumulative, right, which is cum sum of the freak, right? Let me print this one. Print family detailed, right? This is nothing but the frequency table is obtained in such a way that a number of elements are added to it. We have family size, names, frequency. These are percentages. The last one is cumulative. So this is nothing but somewhat detailed angle per frequency for family size. Or in short, this can be created by using freak function from the disk tools house directly, right? Let me hit run. This is nothing but using one line command we come up with this one, but it has tried to group it to classes. It is possible, as the case may be. These are classes now, from 1 to 2, family size from 2 to 3. So it has proceed to plot the family size variable from its family size frequency table, right? So how can we plot the bar plot of this variable? Using bar plot function, which takes the frequency table, which is family size frequency. Let me run this one and I come up with this plot, right? This is nothing but the bar plot for our family size data, where this x is the distinct values, this one are frequencies. So let me add this main title, x label, y label to this one, right? Let me add main title by main statement here, bar plot for family size data, right? X label is nothing but family size. Y label is frequency. Color can also be changed into light green, for example. light green, right? Let me run this one, right? This is now more informative than the previous one, right? This is nothing but the bar plot for family size data is the main title of this plot. The label of the y-axis is frequency, the x-axis takes title of or label family size. At a glance of sight, this plot seems to be normal distribution too. By central limit theorem, at the end, the number of observations is high, everything goes to normal distribution. So this is the approximation of normal distribution, as you can see from this plot.